So I'm Ronnie. I'm part of this team called the API Academy. I gave myself this title of Director of Design because I wanted to focus on the design aspects of this whole space. And somewhere along the line, we found ourselves focusing a lot on this world of microservices. Maybe 2 years ago, 2.5 years ago, this word started popping up. We started exploring, what is this? What does it mean, right? How is it going to impact the people who we talk to? So because I have one of the first sessions today, I wanted to kind of give you something. And what I want to give you is a way of framing this discussion. Because one of the challenges that we had was that there's a lot of information. And over the last few years, we've seen that conversation kind of flow and change and evolve. There's lots of opinion, right? Lots of guidance, lots of perspectives. But putting it all together was actually quite a challenge. And one of the things we found, kind of by accident, kind of by just struggling to figure out what all of this means, was a model, a way of figuring out which parts might be useful and which parts maybe I don't care as much about. But I'm kind of dancing around something here, and that's this question of what are these? And a lot of the stuff in our industry tends to be conceptual now. So even if we're talking about APIs, what do APIs mean here? What do APIs mean there? We don't have these kind of concrete definitions anymore. And microservices is definitely an example of that. If we look for a definition, we could go to James Lewis and Martin Fowler, right? Martin Fowler has an article on his blog. James Lewis and Martin Fowler wrote it together. I've listed the characteristics they define. There's 9 of them. If you go to the page, you're not going to see 9 characteristics listed like this. What you'll see is a 3,000, 4,000 word description of what microservices are. Now this is significant because the story of microservice has a lot to do with this article and with that person, James Lewis. The story, as Lewis tells us, is there was a meeting of architects from different companies who all got together to talk about some of the problems they were facing, typical solutions. It's something they did regularly, get together and talk about work stuff. And in that meeting, what they noticed was there was a pattern developing. They were all kind of solving similar problems in a very similar way. And someone, it might have been James Lewis, labeled that, hey, this is we'll call it a microservice. And as soon as this thing got a label, it took off. Right? It suddenly became something we could use in conversation. I'm doing microservices, and everyone wants to join the microservices club. So if this is the authority, there's a few things we noticed. First of all, it's big, right? There's lots of stuff. The second thing we notice is it's not all technical stuff. The Lewis-Fowler version includes things like componentization, data, but also things like products, not projects, which are vastly different from how do I code? Here's a different view. Fred George is a software architect, consultant, originally from ThoughtWorks. Before that, I think IBM. Fred George has been building software for a long time. And he's been preaching and talking about and evangelizing a way of building software that essentially is microservices before we give it the label, just like many people have been doing, right? The thing about microservices is it's a label for something that already existed. George does not provide a definition of microservices as far as I'm aware in the talks I've seen, but he does outline some principles. This is from one of his talks. The principles are vaguely similar to Lewis and Fowler, but there's some differences, right, if we look closely. Lewis and Fowler talk about components, kind of modularization. Fred George actually calls out size, small, right? He says it should be small. He talks about loose coupling, but also introduces flow. He talks about having multiple versions, that you could have more of the same component running and they could be different versions and it should all be able to sort itself out. And for the first time, we see some introduction of monitoring, right? Of visibility, getting information about what's happening. Most telling, for George's perspective, is this idea of publishing. If you listen to Fred George talk about microservices architecture, you leave believing that you must implement event-driven architecture, right? If you follow Fred George's school of microservices, you would implement some kind of event bus, right? And you're unlikely to do synchronous HTTP. Here's a third view, an implementer, Adrian Cocroft, right, who worked at Netflix. In one of his presentations, he tries to define microservices. And now we actually have a nice, tight, constrained definition. Look, loosely coupled service-oriented architecture with bounded context. So that's useful, right? Now we have something that I can put on a bumper sticker. But the problem is this word, right? So once we define microservices using this word, we're essentially back where we started. And now I would do 3 slides on what is services-oriented architecture. And depending on who you talk to, those slides might look vaguely similar to what Lewis and Fowler describe, what Fred George describes, or what others describe. Now, I don't know if you know this, but we wrote a book. This is that book. The publishers told us, you can't write a book called Microservice Architecture and not define microservice architecture. And we definitely tried not to define it, but we also wanted to sell copies. So fine. So there is a definition in the book. Now, we took a slightly different approach. We actually turned this into 2 definitions. So we provide a definition for microservice. That's the component, right? A definition for the small piece. Independently deployable, blah, 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 bounded, etc. It rolls off your tongue. And this other definition for the architecture. And for us, this was a kind of a key message that there are the small things and there's the big thing. What this is in disguise, of course, is not really a definition as much as, again, a list of characteristics written in prose. Independent deployability, bounded scope, interoperability, message-based, highly automated, evolvable, capability aligned. So again, we have something that's vaguely similar to the other views you've heard, but maybe a little bit different. So I've decided I'll take all of those pieces, right, and throw them onto a board. So then this could be microservices. This is kind of like the aggregate of what you've heard so far. Now, do me a favor, don't turn this into now a definition, right? Don't say now this is microservices, because I'm only doing this to illustrate a point. First of all, it seems like there's too much stuff, right? This seems just difficult to just comprehend. Like, how do you do all of this? The other thing that I find interesting, Fred George talks about small. The name of this thing is microservices. And when you first get into this domain, I know I did this, the tendency is to focus on small. I mean, it's called microservices. So it must be about making services that are small. And as soon as you do that, someone slaps you in the face and says, no, you should not be measuring by lines of code. If you start only trying to make small services, you'll end up in trouble. One of the things that happens when you try and make the services small is you realize that the system around it gets more complex. Right? This is something you won't be able to escape. And it's been captured already in computer science. Fred Brooks, author of the Mythical Man Month, wrote this paper on software complexity, where he points this out that some of the stuff you do, right, the things that your application exists for, the problems it solves, introduce an essential complexity. You can get rid of complexity, right? But Brooks positions that as an accidental complexity. But there's an essential complexity that exists. So if all we do is componentize, usually what happens is we just push the complexity somewhere else, and then the follow-up to this is to someone else. So you might start with small, but you'll end up having to do some other things to make this work. What I struggle with is this now microservices? At what point is it not, and at what point does it become? Is this microservices because I have more than 50%, or is it a matter of I need to light up the correct squares? Right? Is there a minimum viable microservices? Fowler tries to address this with things like you must be this tall, but I'm not fully convinced. Here's what we found. It's useful to take all this stuff and use a model to figure it out. We've got paying attention to the small pieces, the components, the microservices themselves. There's a whole world of design in there. There's the bigger solution or architecture or whatever you want to call this macro piece, the coordination of the services. There's the platforms, the Dockers, the processes, things like Agile and Lean. And then behind it all, you have things like Conway's Law impacting organizations and the culture. So it means you have to be able to do things in this entire space. And the other frustrating part here is if I make a change here, this is a complex system, and because of the interdependencies, a change here can have an impact everywhere. So somehow we're supposed to understand all of that as well, and it's hard. So to try and find a path through all of this, what we found is it's better to stop looking at what they are and start going back to basics and thinking about why they exist, right? What is the reason? Why even have a desire for microservices in the first place? What becomes obvious right away is this is about change, right? It's a way of managing change in software applications. I would be kind of surprised if you wanted to adopt microservices for an application you're building once and you're not going to do anything with after. Another way to look at this, I mean, this is kind of a definition for what being a professional software engineer is, right? When you first start learning how to code, maybe you can write hello world. You make the program do what it's supposed to do. But someone who's a professional, who has real industry experience, who's been through the hard times, knows that there are ways to design software to make the changing requirements, to make the future stuff that's going to happen easier, to make it cheaper in the long run. But this still doesn't get to the heart of microservices because that's pretty general, right? That's, to be a good software engineer, we do that. When we dug deeper, we actually found that there's this thing, right? The essence of what microservices seem to be about is this way of building software that uses these four things: speed, safety, scale, and harmony, right? As it relates to change. So let's start with this idea of speed. Speed is very important at the moment. Just about every organization I talk to talks about their need to introduce changes quicker. When we talk to business teams, they're talking about a desire to change these things faster, change their business model, their products, introduce new experiences, change the experiences we have. We don't want just one UX for our customers on one channel. We want many small niche experiences. How do we enable that? There's a certain level of, let's call it Amazon envy, right, in large organizations. It's hard to have conversations with business teams where they talk about change, where they don't bring up something that Amazon does. A lot of them are absorbing Amazon principles because maybe that's the secret to getting faster. It's possible. Of course, underlying this is our world, right? The applications, the data models, the architecture. So somehow we have to be able to change these things quickly because we're told there's a desire to change these things quickly. And here we have a different kind of envy, right? This is the domain of Netflix envy. What would Netflix do? Is the answer to every question. So that's speed, right? That's not Captain Picard. That's supposed to be a picture of Jeff Bezos. But I couldn't capture the essence of Jeff Bezos. But here's Bezos' letter to shareholders from 2015. He talks about speed. He talks about continuing to have Amazon be this company that's big, but it's going to move fast, like a small company, right? And this is what's so attractive to big banks, to insurance companies, to organizations that classically we wouldn't think of as having this mentality, but increasingly they do. So if I wanted to increase speed in our technology platform, here are some ways we could do it. We can implement zero bureaucracy. No one asks for permission for anything, right? How about no validation? We don't need to test. This is, by definition, faster. We should increase the frequency of change. Let's not wait for specific release windows. You should be allowed to change things when you want. Probably we want programmers who have a higher, I don't know, words per minute, but also are good at programming itself. Fast talkers. We should use languages and tools that don't constrain anybody. I don't want to see any static typing, any schema validations, right? No contracts, just freedom. And really, what we want to do is eliminate the environments, right? What we should be coding is in production. I worked at a bank years and years ago, and we had an online banking team. I was part of that team. It wasn't a big team, and the online banking thing was pretty new at the time. And we used to do that. Like you log into production to make a quick change, you change the JSP or the servlet, and it works. So it's not like we've never done this. Facebook had a motto for a while, move fast and break things. Right? So this might sound weird, but some people kind of indicate this is the way to get faster. I mentioned that I worked in a team where people used to log into production and change JSPs. It worked well until someone made a mistake, right? And now I believe if I go back there, if you do that, that's a fireable offense, right? To log into production and change things. And that's because while speed is sexy, safety is necessary, right? We need safety. There are failures that can be catastrophic for businesses. Generally speaking, this isn't always true, but generally speaking, startups can be less safe, right? Maybe you can apply the Facebook motto when you're small, but end-ups, the opposite of a startup, I guess, is they tend to be more cautious. We can't afford catastrophic failures. I mean, failure will help us in terms of innovation, in terms of things we want to do, but some system failures are really, really bad. So safety matters, right? So how do we increase safety? Well, we know. Strong governance, right? We want more control over the change that happens. We're going to control everything. We'll validate everything that everybody does. In runtime, in design time, we control who comes in the building and who goes out. We'll reduce the change frequency, ideally to 0, but if we must, maybe once a decade. We need programmers who are safer. We want workers who question themselves and question each other and constantly criticize all work. Languages that are constrained, right? So now I want more structure, more tight binding, static typing, things like that. And this is a big one, no access to production environments. Now, maybe not to this extreme. I'd say a lot of traditional organizations have been bred to become very good at this, right? I think there's a lot of organizations who are very good at safety now. We've gotten good at that, which might be why safety doesn't get mentioned, because there's a desire to move more towards speed. It's possible. Where this gets more complicated is with scale. Scaling is about, changing the quantity. 3 kinds of scale that really matter, it seems, in microservices. One is this idea of the demand increasing, right? So lots of requests, lots of users. We need a system that can support that. The other is this idea of distance, right? If the pieces are very far away, if our microservices architecture isn't all contained in one cloud environment, but geographically disparate, that has an impact. And probably the one maybe we don't think about enough is scaling the organization. What works for a 10-person company may not work in the same way for a 10,000-person company, right? How do we scale what we're doing as an organization grows? And that becomes an interesting challenge. All of this gets wrapped up with harmony. If I made this little chart with my examples that I gave you of increasing speed and safety, what we see is it's really opposing forces, right? More autonomy could give us speed, more control would give us safety, decentralization versus centralization, embracing risk versus avoiding risk. When you look at something like this, you kind of get the feeling of, it's a trade-off discussion. And we're going to have to decide where we stand on this. Are we going to be faster or are we going to be safer? What we actually found when we looked at how people build microservices applications was that somehow they're cheating this whole trade-off. They're actually able to increase speed and safety. Or they're able to increase speed without really hurting their ability to build things in a safe way. And that was a big penny-dropping moment for us. Because this seems to be the crux of what we should all be trying to do, right? This should be one of the key goals when designing your microservices system. How can you increase the speed of change without introducing unnecessary risk? What you need is not necessarily balance or trade-offs or anything like that. You need some kind of harmony, a way for both of these concepts to thrive. There's lots of ways you can cheat that trade-off, right? One of the key ones is automation. By automating, we remove human error as a safety risk, and we increase speed because things can happen faster. Now, there's always a cost, right? Introducing automation has the effect of perhaps reducing flexibility. Now we have tools, machines that do things where previously someone could do whatever they wanted. So you have to introduce the right automation. We can use better processes, better tools. We can change the organizational design, right? Improve the architecture, design the culture, and maybe most importantly, move the change boundaries, right? One of the reasons that microservices is compelling is because you put a boundary around something. If you make that boundary too small, then you might get faster, but the complexity you introduce makes the whole thing kind of unsafe, unstable. If you make the boundary too big, maybe you can see better what's going on, but now the speed goes down. There's some point at which the boundary becomes just right, given that you've got the other things going on, right? This seems to be one of the primary pursuits if you're designing that kind of system. So ideally now, we should be able to look at a list like this and not worry too much about which one of these we've ticked, right? It doesn't matter exactly how you want to define a microservice. As long as you have this fundamental goal of building your application in the microservices way. I mentioned Facebook had this motto, right? Most of us in this room probably know they've changed that motto. They changed it in 2014 to something that's far less catchy, right? Move fast with stable infra is so not, something you want to put on a slide. But I mean, this is compromise, but it could also be harmony. We will get perhaps less changes happening here so that we can have an increased rate of change happening on top of it. That could be one plan of attack. So taking this idea, speed and safety at scale and in harmony, if we want to apply it, the first thing that seems to be important is establishing the right boundaries everywhere. So boundaries don't just mean in your code for the components, but also within the organization, right? Boundaries seem to be essential to this whole domain. The second thing is we need to build a system that makes change both easy and safe, right? So we want to raise both the speed and safety and build interfaces, systems, process tools, all of that stuff around it, right? So we need the right processes. And I know it's an ugly word for microservices, but standards. There is no system that exists that doesn't have some form of standardization. Now, how much standardization and which standards, that's the key question here. Fourth point is you're going to have to steer this system, right? So we don't get to deterministically design the system and then implement the system. Instead, you have to touch it and poke it and change it and measure it and slowly steer it to where you need it to go. And maybe most importantly is the last point, which is at the bottom, so maybe hard to see. These things that I'm using here, right, easy, safe, they're a product of two things. Context, so who works here, what do we do, what's our industry, and time. What's true today could be totally different tomorrow. Somehow you need to build a system that accommodates all of this. So that's the way. You're going to hear a lot of wonderful talks today. And if at any point you start to wonder, how does this fit in with that, and where does this go? This is what I'm giving you. This is how I've been able to kind of deconstruct and reconstruct a lot of the microservice discussion. Think about it in terms of what does it do for speed and safety? Would it work at scale? Could I harmonize this in my own organization? And hopefully that gives you a little added bonus for the day. Thank you.